All right, so yes, my name is Eliot Kimber. We're going to be talking about Docker containers for DITA. So, and I'm going to go a little bit fast, so maybe I have time for an actual demo. So first, going to talk about what Docker is. So, what is Docker? So fundamentally, it's containerized software. It's an open source project, so even though Docker is supported by a commercial company, the fundamental technology is open source, and you can use it for open source things without cost. So it's putting software into containers, right? But of course, I'm not telling you what a container is. We'll get to that in a minute. The key thing, and the reason I'm focusing on using Docker with the DITA Open Toolkit is that it makes provisioning and deploying software and data easier, right? I see it primarily as a way of addressing some serious configuration management challenges in the deployment of software. All right, so what is a container? A container is a small virtual Linux machine. And it's the way the idea with containers is that you put just one program in each container, or maybe just one data set. And then you have multiple containers that are run by a container manager. And so you have multiple containers, they're all doing their own thing, but they're all coordinated, they're running in a shared space so they can communicate with each other. The idea also is that by having container managers on different platforms, the same containers, the same actual container images can run on any platform, right? And that's certainly the case for Linux, Windows, and Mac OS. I don't know, are there any other operating systems? I don't know if anybody's made a Docker container for Plan 9, but maybe somebody has. Sounds like something Yarno would do. All right, so how do containers help? Certainly that sounds like something Don Day would do, actually, now that I think about it. So, yeah, Robert knows what I'm talking about. So how do containers help? So they provide a consistent and controllable operation environment. So who here has tried to run the Open Toolkit and not had Java or not had the right version of Java? I would expect everybody to raise your hand, right? Because that always happens, right? So that's a big problem. Well, who's tried to get a client to run something and they didn't have the right Java or didn't have Java installed, or, you know, they were on Windows or whatever, right? So this removes all of those local configuration details. Containers can be fetched automatically over the web. And a lot of the value that I see the Docker company providing is they have this whole web-based infrastructure for simply making containers available in about as convenient way as it can be. And so that removes the need for separate installation. So basically, instead of having to get a package, install it, and run it, you just say, run this container. If it's not available locally, the Docker infrastructure will try to find it. If it finds it, it downloads it, does what it needs to do, and then runs it. Another interesting thing is that containers share common parts. So containers are built on this idea of layered file systems. And so if two containers have the same layer in their layers of file systems, that layer actually only exists once in your local environment. Right, so it allows you to share common parts, and that minimizes both network traffic and local storage. So for example, if I fetch a container and then I want to fetch another one that's built on the same basic parts, the Docker system only fetches the layers that are different. It doesn't refetch the entire thing. Right, so that could have, especially in like a continuous integration environment, a testing environment, that could have some important implications just for minimizing your network traffic. And then the other thing is that it's easy to create new containers from existing containers. And if I don't run out of time, I will demonstrate that. All right, so this all goes to simplifying configuration management. So not only can have individual containers that are useful, but you can configure and manage sets of multiple containers as a coordinated set. And so Docker has this mechanism called Docker config? No. Compose, Docker Compose, thank you. Docker Compose, you can create a fairly simple configuration file, defines and configures multiple containers that are all going to be working together. Then you just run that script, you just run that file and it all works. So this turns out to make putting together really arbitrarily complex systems of containers relatively easy. I mean, easy enough that somebody like me can do it. So for example, you might have DITA Open Toolkit, you might have a continuous integration environment, you might have a web server, you might have several components that all need to work together. Those can all be in different containers. You can define how they relate to each other in this compose file, which is a script, and then you just run it. And I should be able to demonstrate that as well. All right, I have to have an architecture picture. Who cares? You can go to the Docker website if you care about those details. All right, so how do you use Docker? So you install the Docker system on your host computer. So there's now Docker for Windows, Docker's for Mac OS. If you're a Linux person, you just install the Linux Docker machine, however you do that. I have no idea because I don't do that kind of thing. But then you start the Docker machine, and then you use Docker commands to manage your containers. And that's really all there is to it. And it's really not more complicated than that for basic stuff. I mean, if you're getting into like production system deployment and hard network things, yeah, well, that's a different story. But just to use it on your local machine or in a shared machine that you're managing for a department or something, or in the context of continuous integration or testing, it's pretty straightforward. So where do you get your containers, right? Well, you can get them from Docker Hub. So Docker Hub is the central public repository for containers. It's comparable to something like Maven. Anybody can put stuff up there. Once it's up there, anybody can get it. So it's public, but it's free, and it's easy to put things up there. If you're a big company and you use Docker internally, you might have an internal Docker Hub. You can even share Docker images as zip files if for some reason it doesn't work to share the actual image. And of course, in your local development environment, you can create new containers just using the Docker tools for creating containers locally. And then most well-known tools will have containers in Docker Hub. So for example, any web server that you use, any Linux distribution you want, all the database tools, BaseX, Exist, MarkLogic, all have containers that you can just get from Docker Hub and either use directly or easily make your own variants of those containers just by updating the configuration file. So it makes it really easy to pull these things together. Where, I mean, if you've has anybody here tried to install, I don't know, Nginx on their local machine? Nginx? Anybody know what that is? All right, well, don't worry about it. You can just get the container and you're done. It's easy. All right, so what can you do with a container? You can connect your local file system to your containers. So each container, fundamentally, it's a completely isolated environment, and its data storage it's not static, but it's not persistent. That is, I can change the data inside a container, but as soon as I turn that container off, poof, those changes go away. Right? So if you're doing something, say, generating output, you probably don't want that to happen, right? As soon as the container stops, poof, your output went away. So you can connect those containers to your local file system. So for example, you can run the Open Toolkit inside a container, but it can get the files from and store the results back to directories on your local system. You can make one container's data available to another container. Right? So a really important feature of the DITA Open Toolkit is that it manages the entity resolution catalog for all of your schemas, all your DTDs, other things as well. That's a really important service that other tools might depend on. If you have the Open Toolkit in one container, components running in another container can access that catalog directly out of the container and just have it. Right, so you can separate those two configuration concerns, but connecting them together is still easy. And then you can also create data containers that just have data. So for example, you might have a pre-prepared data set that you use for demo purposes or testing or whatever. You can just put that in a container, and then other containers can use that data easily without having to make their own copy of it. You can also use it as a way of delivering data because it's easy to copy data out of a container to your local machine. So it can have some interesting distribution and deployment value there. All right, so DITA-related containers. DITA Open Toolkit. So I maintain various containers for the DITA-Open Toolkit. So different versions of the Open Toolkit, different combinations of plugins. And so that makes it easy to run the DITA-Open Toolkit without worrying about the local environment, right? Because I'm on a Mac, but my clients are on Windows, and Yarno only does development under Linux. And so, you know, if we have everything running in one environment, it makes things a little bit easier. I also maintain a container for the DITA demo content collection. That's the Thunderbird materials that Gnostics contributed to the community. Have that in a data container, and that way it's easy to integrate with larger systems that need some data to chew on. It's just right there. Easy to get. And then the DITA for Small Teams project is a project that I'm currently trying to get to a workable state that's entirely built around using containers to organize systems of components that you plug together to form a complete DITA-aware content management system. All right, so that is, wow. Have I already, oh, I'm sorry, I can't read a clock. I saw 18:30 on my clock, and I was like, is it already the half hour? No, okay. All right, sorry. All right, so Docker Hub. So Docker Hub, it's a public repository of container images. Anyone can create their own organization, and then you can put images in Docker Hub. And when you run Docker, if you just give the name of a container as it's managed on the hub, it'll look for it. If it finds it, it'll bring it down. Once you've got it, it doesn't need to do that again. You can also connect Docker Hub to GitHub or Bitbucket so that you use GitHub or Bitbucket to manage your configuration files. Anytime you push a new version up there, it automatically generates a new image for you. So that makes managing your images and keeping them up to date pretty easy. All right. So how would I deploy a container? Let's say I want to make one. So you can make your container image locally, right, to test it. Then you can commit your Docker configuration file to GitHub. And then on Docker Hub, you create a repository. Actually, as I was just going through this exercise earlier today, this is actually a little bit backwards. Really, you just set up an automated build, you point it to the right GitHub repository, and it just does everything. It's really, once you've done it a time or two, you realize just how easy it is. Docker Compose, so I mentioned this before, you can configure multiple containers to work as a unit. So for example, in the DITA for Small Teams case, I have BaseX, I have GitLab, I have the DITA-Open Toolkit, I have a web server, all working together, each one in a different container, but they're coordinated. So they know about the volumes that they use, they know about their, if they're on specific ports for the network connections, they know about that. This also allows containers can talk to each other over the network using their container names. You don't have to like configure IP addresses or anything. And then you just have this one command, Docker Compose, runs it, and assuming that everything's configured correctly, it just works. All right, Docker for Windows and Mac. This is new since really this summer. But Docker has now really nice integrations with Windows and Mac. They've made it about as easy to use as it could be. They're really easy to install, really nothing to manage. You can mount local file systems, and the containers use the local network for access. So for example, I'll show an example of this. If you're running a web server in a container under Windows for Mac, Docker for Mac or Windows, you can just get to it using localhost and whatever port you've bound it to. So that's very easy, no extra networking stuff you have to worry about. So basically what that means is that software that's running in a container, as far as the things outside those containers are concerned, especially in terms of network access or file system access, they're just there. They're indistinguishable from programs running natively on your machine, but they're not there. So that means you can turn them off quickly, you can get rid of them quickly, you can update them quickly. You don't have to uninstall, you don't have to have like 18 different versions of the Open Toolkit lying around on your hard drive like I do. You just have things. All right, so demo. All right, let's see, how much time do I have? Oh, I got plenty of time. I have almost 15 minutes, okay. So let's see what we can do here. Now, had I thought through this demo carefully? No. I thought through a little bit. All right. So, let's see. What do I have here? Where am I? All right, here's what I wanted to show, yes. Okay. Make this big enough so we can see it. Okay, so, there we go. So what I have here is, there is a Docker image called DITA-OT, which is the organization name, / DITA-OT, which is the container name. That has in it a completely generic distribution of the DITA Open Toolkit. Version, I think this should be version 2.3.3, I think, if I've kept it up to date. I'm giving it we see Docker run, so that's the command that's going to run whatever image I've said. -v here, this is mapping a local directory to a directory in the container. I can. Let me make the window smaller so it'll wrap properly. There we go. And now scroll around. There, is that easy? Can you read that? Okay. Yeah. So when you configure a container, you can say I expose to the world these directories, what they call volumes, right? And so those become basically mount points. So I can mount my own local directory over those directories. So here I'm saying I'm mounting my entire home directory onto this directory DITA-OT data. And that'll just give the Open Toolkit here, I can then get access to anything in my home directory. So then I'm just giving it as input, some demo data that I happen to have on my machine. In this case, it's the Thunderbird user guide. And then as output, I'm writing it to a directory that will actually be on my machine, which is this temp web delivery directory. I'm saying run the PDF2 transform and -v, but I don't want to run PDF2. I want to run HTML. That's more interesting. All right, so assuming my machine is going, there we go. So now this is running the toolkit inside this container, right? So that's running inside the container. And it should be done. Let's see, is it done? Yes, there we go, so it's done. All right. So now, let's see. Web delivery, yes, there we go. So this is my web delivery directory, and you can see there's an index.html. Okay, so now I have another container running. Let's go here. If I say Docker PS, that will list all the containers that are actively running on this machine. And you can see I have this container, dfst caddy-dfst. Caddy is a nice little web server. It's like easier to configure than Tomcat or Nginx. So I'm just using it there. So this is running, it's a web server. I've bound it to port 80. So if I say HTTP localhost, there you go. That's the HTML content that I just published being served through that web server running in a different container, right? So now, for example, I have other clients for whom I have basically a copy of their production Tomcat image running in another container. So now I can just spin that up where I just turn this one off, turn that one on, boom, now I'm looking at their stuff. Or, I can quickly change my configuration on my machine for different things, which I need as as somebody working with 50 different clients. That's very handy. But it also means that I didn't have to install this on my local machine, and then have to update that every time that software updates. If a new version of Caddy is released, I can just get the new image and I'll get the new version. Let's see. Okay, so that's right. Yes, right. All I have to do is tell the Open Toolkit to write to that folder. That's the same one I told Caddy to look at. Right. So I have one local folder, 2 different containers are looking at that same folder. Right. Right. Let's see. So you may have heard this morning that there was a new version of the Open Toolkit released. 2.4, correct. So here is my, well, you can't see that. So here's my project where I maintain the Docker configuration files for the Open Toolkit, right? And so, ooh, scroll. All right. So this is, are we at, there we go. Okay, so this is the Docker file. This is managed in a Git repository, and currently you can see it reflects version 2.3.2. So apparently I never updated it for 2.3 because, you know, I'm lazy. All right, so I'm going to update it for 2.4. Yeah? So I've got an environment variable that takes the version number. That version is referenced various other places. Here in particular is where it's going to get the installation package. If you look at this Docker file, this is basically a shell script that's doing all the things that need to be done in a Linux operating environment to configure the container to be ready to go. Those things are done statically, the result is saved, and that becomes the image of the container image. So now, I've made that change. Let's see. Yeah, there, I changed that file. Okay, so I'm pushing this to GitHub. Now, on hub.docker.com, where is that? No, that's not the one I wanted. All right, so different organization, DITA-OT, DITA-OT base, build details. You can see it's building the latest version right now because I committed my Docker file. Yeah? So while it's doing that, we'll update the other one. So one of the challenges with the DITA-OT is that you're always going to want to change the configuration. You're going to want to add different, you're going to want to add your own plugins or whatever, right? So because of the way Docker works, because once you create a container, the image is fixed, right? I can't take a container and just use, I can't use DITA commands to install new plugins into an existing container, right? Because the command will run, it'll think it did the right thing, but the file system in the container doesn't actually change, right? So to get around that, what I have is I have a pattern where I have a base container that does everything except set up the volumes that are exposed. Once you set up the volumes, you can't change the container. So here I have the DITA-OT, the image, the definition for the working container, and you can say it says from DITA-OT, DITA-OT base. OT base is the one I just changed, right? And so what this means is take that other container as my starting point and then add these layers to it, right? And that shows you how quickly and easily you can create new containers as variants of existing containers, right? And the only things that I'm doing here is I'm setting the volume, and then I'm just saying, when you run the container, if you don't give it a command, run this command. Yep. And nothing here changes because I changed the version of the Open Toolkit, but I need to either push it to GitHub or just go and trigger the rebuild so that it'll get, you notice that it's saying from DITA-OT / DITA-OT base, and it's not giving a version. I could give further, I could say colon and a specific tag, and that would get that version of the container, but if I don't say anything, I get the latest. Well, I made a new latest, right? Because now the latest is 2.4, so I need to get a new one. So if I come over here, and I come to DITA-OT, I believe, no, that's right, I forgot. You're able to connect one container to another one so that if the other one changes, this one changes. So now it's building a new one. So sometime in the next 2 or 3 minutes, you will be able to get a container with the 2.4 Open Toolkit ready to use. Yeah? I have 5 minutes. Okay. So, but, all right, yeah, fine. Okay, I can get the Open Toolkit. But what if I want my own configuration? Yes. So, as I was saying earlier, when I was trying to disrupt Robert's talk, I've created a new plugin for internationalization. And does really cool stuff, but it requires a really tedious configuration change. In particular, it requires that I set this Java property to something different before running the toolkit. But here, I can do that in a Docker file. Yeah? So here I'm saying, from DITA-OT base, create this new container that all it does is it's installing a plugin. So this is actually using the DITA-OT 2.x feature, which is very nice, which is that I can install plugins. I can install plugins from zip files that are on the web, right? So I've deployed my plugin. I mean, I've made a package of my plugin available on GitHub as a zip file. I can install that right here. Then I'm setting the antops to set up my tedious configuration change, and that's it. So this is a very small delta on top of that. And then, again, to make it usable, I use that base one to then create my volume and run. Right, so this is actually just an exact copy of the base DITA-OT one, but I'm using the DITA community OT I18N base, not the DITA-OT base. That's the only difference. So then I pushed both of those to GitHub and created so not DITA-OT, different organization, DITA community, right? So now, in DITA community, I should have more repositories. Oh, just go down. There we go. Yeah. So there's my DITA-OT I18 in base, DITA-OT I18 in, right? Now, I did that this morning in about 10 minutes. Well, it took me longer because I named them wrong, and then I had to delete them and rename them and get. But anyway, if I had done it right the first time, it would have taken me 10 minutes, right? So they're there. So now I can run these and have full access to my internationalization code with the tedious configuration that would otherwise be a challenge to maintain in my local system. I know because I've had to do that to test my code. But here it's in a container. I just choose this container instead of the other one. Everything else is the same. All the command parameters are the same. Everything's the same. The local file system is the same. And it just works. Right? To me, that means configuration management problem. Well, I don't know if solved is the right word, but manageable, right? So I will show you what my normal. So this is my directory with all of my different Open Toolkit versions that sit around. Now, you may remember last year I talked about using Git to manage the different configurations of your Open Toolkit. Yeah, well, George made that unnecessary by enhancing Oxygen, but that just became unwieldy as well. So I got a bigger hard drive and now I do this. But I could just do it with Docker containers as well. All right. So in the last 30 seconds, so Docker.com has really good documentation. There's a book you can get called the Docker book. I would say just install Docker and try it out. They've got a really nice little, just how to, quick start kind of tutorial you can go through. That's where the DITA-OT project is, and the documentation for that, and then Docker Hub for the DITA Open Toolkit. All right, and that is all of my time.
Thank you, Eliot.